Hello, hello, hello. Check out this awesome future pop music. I am loving it, but no, let's get rid of that. Good afternoon, good evening, good night, or good morning, wherever you are watching us from. This is Developing with CockroachDB, a program that's developer focused through a series of workshops and office hours to help you tackle your biggest developer aspirations. And how can you get the most out of CockroachDB? How can we help you get the most out of CockroachDB? Hopefully you know a little bit of SQL, a little bit of Postgres, because it makes the transition easier. If you've taken some Cockroach University classes, if you're new to Cockroach Cloud or CockroachDB serverless, bring us onto your journey. Let us know how we can help you streamline that experience. Today is a module on JSON optimization. Tomorrow is office hours, same bat time, same bat channel, however you're watching right now. You can watch again tomorrow, office hours, which is basically an AMA. But also, if you have any questions that we don't get to today, we'll start with those tomorrow. Also, this is not your only channel of communication, but one channel to become excellent developers. We've also got Cockroach University, Slack, forum. Please let us know how we can help you. And so I'd like to first introduce my experts today, starting with Fabio. Not even going to try to pronounce that last name. Fabulous enterprise architect. Fabio, tell me how you came to Cockroach Labs, how you started playing with data.
Hi, Rain. Thank you for having me here. My name is Fabio Girardello. Sometimes it's very hard to pronounce for myself too, but I've been here for Cockroach Labs for now a little bit over a year, and I joined as an enterprise architect. I work with enterprise customers to deploy, configure, and set up Cockroach DB in their infrastructure.
Cool. And how'd you get started with data?
So I started first at Cloudera back 4 years ago, starting in the big data space. I joined as a sales engineer, first for the partner network, then moved into some other internal roles. And I had a great overview of really the entire ecosystem, because Cloudera used to cover a lot of the edge to AI workflow. And then I got a great opportunity to join Cockroach Labs, and that's where I am.
Nice. And also we have John St. John, also an enterprise architect. Tell me about your path to Cockroach Labs and data.
Sure. Like Fabio, I'm an enterprise architect. Work with our customers on deploying and integrating Cockroach DB into their systems, particularly their production systems, optimizing them. I've been here a bit shorter time than Fabio, about 3.5 months, getting close to 4 months. Nice. And prior to this, I worked for a little bit of a different company. It was a privacy startup, working on developing applications to help people protect their privacy, and also building a platform to offer that to companies that want to do the same. And so I worked in the solutions architecture, also engineering space. Prior to that, spent quite a few years working in application development, database development, cloud architecture, those type of areas. So it's been a great journey to get here, and I'm loving being a part of what we're doing.
Nice. And I already have a question on here, which I want to highlight before I introduce myself. David, yes, recording is always available on the YouTube channel, and that is youtube.com/CockroachDB. I should capitalize that a little bit better. But definitely cannot wait to hear what you think of the show, even if it's after or later on. And I am Rain. I am a developer advocate here at Cockroach Labs. I'm a bit of a data noob in that I played with it in the late 90s. I played with MySQL in the late 90s, early 2000s when I was a web developer. And I am back to it and getting to know distributed data and actually NoSQL and all of the fancy stuff. Thank you, Adrian, and thank you, David, for the question. Getting right to the point, though, we are talking JSON optimization. Talk to me about what we're learning today, Fabio.
Yes, so today's workshop or module is around how CockroachDB handles JSON objects, support for JSON objects, functions available in the database, specifically for JSON objects, how to manipulate the data, extract data, work with the data, and of course, how to optimize it, how to improve query performance, how to improve the general performance of the database when dealing with the JSON objects.
Awesome. Let's get started. You're sharing your screen today, yeah, Fabio?
Yes, I am. I have a few slides. Thank you for giving me the permission. So here I have a JSON optimization. So here's the agenda. I like to start always with 3 slides for the architecture review. In case it's your first time you join these live stream videos and you're not very familiar with CockroachDB, or you are, but you slightly forgot exactly the few details, I have 3 slides that introduce review the architecture. And then we go straight to the use cases for JSON, and we drill down into the various points, imported data, query, using functions, using operators, and we conclude with performance considerations. How you can, what can you use to improve your performance in querying JSON data? And we also have labs at the end. We're going to go through some labs connecting my terminal to CockroachDB serverless and do a few exercises to consolidate the points that we discussed during the slides.
And those labs are already available on github.com/cockroachlabs/developer-success. Look for JSON optimization, and those are Apache license. You're welcome to play, give us feedback, everything else.
Yes, exactly. So I'll share the link later on too when I go to my screen. So let's go further, review first the architecture. So CockroachDB is a dynamically distributed, a transactional key value database management system with a SQL interface. You as a developer will always interface through the SQL. So you always handle communication with database via the SQL interface. How is implemented? CockroachDB is implemented as a cluster of nodes where each node is equal in its function to any other node in a shared nothing architecture. Each node is a master, each node is a gateway, each node is an executor. All are exactly the same function. Each node is implemented, is an independent process that holds both the database logic as well as a portion of the data, and is also location aware. It knows it's part of a larger cluster. It knows how to communicate with all its peers. Transactions are distributed and are executed with the highest logical isolation level, the serializable isolation level. And therefore, we can guarantee that the transactions are ACID compliant. The database can then be, the data can be geopartitioned, data can be pinned across regions and zones, and we replicate the data. Such data is also replicated for resiliency, so we can claim that CockroachDB has a 0 RPO. So drilling under the hood, so what do we have there? We have a key value store. It's a monolithic key space, and it's ordered by key lexicographically. The store is cut into chunks of data. We call these ranges. By default, they are 512 megabytes, but it's configurable. Ranges are then moved based on the activity and how you want to pin your data. Ranges are also replicated, and as we talked before, and spread across the cluster for resiliency. And every table, every index, every object really is mapped in this manner into ranges. But you as a developer, you care, okay, I want to work with a SQL interface. So how does it look like? So here is what a relational table looks like when it's parsed into a key value store. The key holds the information about the table name, which receives a unique identifier across all databases, the index, the family, primary key, in this case, you see as a column ID, but it could be a composite key too. And finally, you have all the values. And in the value section of the key value, you have all the other columns. So understanding the structure of the key value store is fundamental when it comes to do anything related to query performance, query optimization, geo-partitioning, all sorts of partitioning, and that characterize your deployment. And one final important note is that a table is basically an index, and we sometimes refer to it as a primary. Secondary indices are indices on another field of primary. They depend on primary, but they can store also other columns. They can be exact clone of primary, depending on what you need to do for improving your query performance. Secondary indices also are automatically deleted if you drop the table. And that brings us to the topic of today. So use cases for JSON. So when would you use JSON? So we see in the field the majority of our use cases really a migration. When customers want to migrate to CockroachDB, they happen to have data or some tables in a JSON format, and they want to know, do we support Cockroach? Do we support JSON? Do we support queries on that? So mostly, you can, as I said, is migration from document store databases. We have other cases where maybe your application needs to store some sort of payload. And you don't know what form this payload holds. There are other cases where the nature of the JSON object is dynamic. Sometimes you have some fields, sometimes you don't have them. So there is not a one-to-one mapping to a relational table where you can quite convert it. So in those cases, using a JSON object, you still want to keep that. You want to stay with the JSON, at least for the moment, at least for the time being. And now, John, do you see anything on your side, any other use cases? So do this look appropriate to you?
Yeah, I think this looks good. I think the ones that I've seen a bit are where you have sort of this long tail, maybe the third one, where you have a long tail of maybe properties. One way to think about it might be like a store that might have thousands of different types of products, and then maybe over time you're adding, removing products. So there's some things that will be really consistent between them. Think of like price or weight or something like that. But there's going to be a lot of characteristics of these products that you're not going to query on, but you might be displaying to the user after you retrieve them, or infrequently querying on them. And we'll see some of those optimizations on the JSON data for querying. But in that case, you've got this kind of long tail of dynamic properties that you might want to store as JSON data. And then the other, I think, is what you described as the payload data, where you just have some payload and it might be some deeply nested data, where maybe a lot of the data you're not going to query on. You might pull it out with like a primary key lookup or some other method, and then.
But you need to store it somewhere.
Yeah, exactly. Yeah. Yeah, so I think you hit on the major ones.
Adrian mentioned that it sounds like a good thing to use with a third-party API where you can't control the response. What are your thoughts on that?
That you can control it with an API? What was the question again? Sorry, I think I got distracted.
Where you can't control the response.
Yeah. So I think the idea there might be that you have, you want to be able to store that response and maybe pull some data out of it. Maybe you store those in traditional columns, but maybe you want to keep the actual response. I think in that way, it's kind of that, maybe that fourth, like storing a payload object where the response is the payload, and you have some structure where it may change over time. I can see that being a use case.
Yeah.
What do you think, Fabio?
Right, yes. So generally, we should have support for JSONB object. We prefer to have data stored as key value pairs. That's generally what I suggest all my customers to have, if it's possible. But we recognize that there are cases where you just cannot get away with JSON, at least for the time being, or you really need to refactor your application in other ways. And the JSON have their use, so that's why we decided to support them.
Nice.
Yeah.
And would you do this with a computed column?
Yeah, there are various ways to optimize it, to handle data. You definitely JSONB is an object type in a CockroachDB, so you can work directly as if it was a document store. Nice. But there are ways where you can, and yeah, we go later in the presentation when we talk about optimizing query performance. So what are the things that you can do to improve it? It goes from the ideal is removing the JSON object completely, but you can also have computed columns, you can have inverted indices. There are a few tricks. It depends on the use cases. Where are you comfortable with?
Yeah, cool.
So first thing obviously comes to mind is how do I import the data? So we cannot ingest raw JSON. We want to have it in a flat file, like a CSV file or TSV file, as we will see later in our examples, where and then you insert it that way. So you import it as if it was a string, basically. So here are some examples how you would insert into CockroachDB some SQL payload. So you can see that assuming that we have a table called JTab, that has been defined as a JSON object. We insert the values like normal strings, just the structure inside it happens to be a JSON. And the CockroachDB will store it as a JSONB object. So, or you can, as I mentioned, that probably the most preferred way is importing a table or importing it into directly from a TSV or CSV file located on the public cloud. And this data is delimited by a tab or by a comma, and you import the data that way. On CockroachDB side, while it's a string what you're sending over, we will be interpreting and saving it as a JSONB object type, which allows us to do all sorts of cool functions on top of it. So we have provided a rich set of functions. These are around querying the JSONB object, querying the keys, extracting data, extracting metadata. There is a lot of them. There is a good documentation available online. We're going to go through some of those, some of the key ones that are important, that we think are important, starting with the JSONB object keys. So here, you flatten per row as much as possible, and then you drill down into every object. So in this case, I've imported some data into a table called JSON table. I've added some random JSONB object, and I want to find out for each one of these objects what is the key. And these JSONB object keys iterates through all the items and provides me with a key as in the return message. Another similar one is JSONB each. That returns a list of tuples with the key as well as the payload, so the values. So very quickly, I can go through all of them and return my message in the application as a list of tuples. Pretty convenient. There are operators. I pause a little bit here because I just want to go through the three of them. The first two are very similar in one another in that they are the goal is to extract data. So I open up the JSONB object and I want to drill down. Imagine there are multiple levels inside the JSONB object. So it's a key value, and the value is another dictionary, and there's another dictionary. So how can I drill inside of each of the objects? So this operator allows you to do that. The first one returns a JSONB object, which I can then further query using the same operator over and over. The second one returns me a string, which I can use to print to screen or return the object. It will be for your final value. Here are some examples. The final example, I don't even know how to pronounce it. This is the contain operator. This checks, returns a true or false if the left key value is contained within the right key value, within the right JSONB object. So very handy. It comes up. You will see those later in the labs how we make use of them to extract data, to query data, to make sure we do where clauses in our SQL query.
Is that an @ symbol and then a
Yes.
greater than? Okay.
Yes, it's an @ symbol and a greater than. Okay. While the other one are some sort of arrows. So here are some examples, because I think they speak more than words. In this case, what I'm trying to do, we have imported this table data that contains acquisitions, details of US companies against other US companies. So in this case, what I'm doing is I want to go inside of the acquisition dictionary, acquisition acquiring company, and extracting the name as a string. Notice the double greater operator. And I call it acquiring company name. And then I go again, and I want to acquire the year. And then I want to get the amount. And then I pull a table.
Quick question, Fabio.
Yeah.
When you're chaining together these operators, it looks like it's necessary, if you're going to be kind of going deeper into the nesting, that you need to use kind of the JSONB operator to kind of drill down, and then eventually at the end probably you would use the string operator to return the actual string value. That's
correct? That's yes. So you use the first operator to extract data, to drill down, because that returns you another JSONB object. And finally, when you're ready to extract the data that you want, then you want to parse that as a string. There are situations where you actually want to cast it into an integer in case you want to do operations. And we're going to see that next. Well, what I'm doing now here is I want to have the sum. So how much money was the cost of those acquisitions? So similar as before, I'm acquiring the company name. I'm extracting acquiring company name, the company name that was acquired, and the year. In this case, we cast it as an int, even though really it's not necessary for a year. You don't do operations generally on years. But you do operations on prices. You do operations on this type of values. So in this case, I want to do a sum. So I'm doing an aggregation. But to do aggregation, I need to transform this string, price amount, into an integer. And I do that using the cast function. And then I can extract data. And here I can also have something in the where clause. So I can use my JSONB object and the JSONB operator to do some filtering. I want to filter only those that Oracle Corporation acquired. So I can do that this way. And here we see the first instance of using the contains operator, where we want to make sure that it contains US dollar, basically, acquisitions. And then we filter and we get our table. So now you will see immediately from here, we're doing a lot of operations on JSONB objects. There are ways to optimize that to make sure this is faster. So performance.
Can I ask a quick question, Fabio, on that? When you're casting, if the JSON value is an integer, like when you put it in, is it necessary to cast it? Is it always stored as string, or is that a good practice?
Well, JSON is a string at heart. So it's just a structure of a string. So if you extract data, all data that automatically comes out is going to be string, even if it's a number. So yes, it is necessary to cast the value into a proper format for the aggregator operator, for the aggregation operator, like sum, average, median, max, min, and etc. So you would have to parse price amount in this case into a proper double or integer or any numeric type.
Got it. Thanks.
Yep. And now that brings us really to the performance consideration. So, you remember every time you do this sort of operation with JSONB, you're talking about CPU cycles, because you extracted the JSONB, you're drilling down, and then you're further drilling down, then you need to cast it, then you need to extract it, and you need to do the same thing for the where clause. Those are, again, it depends on the use cases. Are you querying JSONB object all the time? Is it only every now and then? Does it pay out to optimize it? So that's a good question. So what do we offer here? So some good example, these are general best practices. The first thing is try to flatten as much as possible your JSONB object. Don't put the entire database as a single key value entry, because then you haven't solved anything. From our point of view, it looks like we have one single row where on the value side you have this JSONB object, which is huge and contains your entire database. Instead, the idea is you want to have one row per object. And then you can use, once you have it this way, you can use the performance features, inverted indices, computed columns, and column families. So we go first to inverted index. So what is an inverted index? So we create for each one of the key inside of your JSONB object, each key inside of every dictionary inside the JSONB object, we create an index. And that allows us to go straight to the key that you're looking for once you do have a query like this one. So assuming you want to select ID from this JSONB table, where certain condition happens, when in this case, I want to see that my object contains this string, CS@19 equals to this value, whatever. And it takes how many milliseconds? So 655. Now I want to create inverted index. And what will happen for each one of the key, which includes CS@19, there will be an index that has it in the key. So the optimizer can leverage that index and go straight to what it needs to go. So doing the same query, look at now the performance improvement. It's 100 times faster. It only takes 2 milliseconds because it doesn't have to scan through the entire table to find out whether this is true or not. Inverted indexes are very, very powerful. It's a quick and dirty solution to improve your performance. So here is another one. This is a very good example. Actually, we shy away now from the JSONB object. Is a similar concept that applies to the array object, which is something also you might want to work with. So this is the classical needle in a haystack. So what we have created is a table with 1 million rows that look exactly the same. That's the haystack. And then we inserted at the bottom here the needle, which is something that has slightly different values. You see, is now adds a 666. And then I want to query, okay, I want to find that needle. So find me where the value is equal to 666. Well, it takes over a second to find out because he has to scan through each one of them 1 million row, check the value, and find out if 666 is contained in the value part. That's a very slow operation. How about we creating inverted indices? Well, performance speaks for itself, 1.75 milliseconds. So that's extremely faster. Good. I think we got a point of inverted index. It's very easy. It's one command. CockroachDB does it all on your behalf. You don't have to do anything else. Just run that query and your performance is going to be greatly improved. Another way to do that, increasing performance, is, I think, Rain, that's what you mentioned before, computed columns. So you might want to extract the most used columns that you query all the time, where in your where clause, in your select clause, into native CockroachDB values, in CockroachDB types. So that's how you do it. So in this case, we use a different data set. We imported. This is about data about restaurants. And we want to find out what are the best restaurants with the type of food, curry, and sort them, do some good operations. We can do all that using the JSONB object, no problem. The results comes out. But if I can do it, however, over and over, and I really care about performance, then it does pay off to create computed columns for those specific columns that I'm querying all the time. So this is how to do it. So you do an alter table where you add a column and you specify it to be a store. And how do you create that column? You extract the data from another column. So in this case, I'm querying the JSONB object. So they give me the type of food and add it as a column called type of food that is going to be type string in my key value store. Once I've done that, then what is going to happen? And then, of course, I create an index on that column. My performance is going to greatly improve. So here is the same query. This is left is only using the JSONB object. And then the left side, on the right side here, is using the computed columns. And you see the performance improvement. It does pay off. It depends on how many times you query, right, Rain?
Exactly. One of our LinkedIn viewers wants to know if it's a better practice to issue a query against a JSON property using inverted index or computed index when available.
Well, I guess it depends a lot on the use cases. Inverted index is an easy way for having CockroachDB do it all on your behalf. But if you have a lot of keys, then it's going to be also a lot of data that you have to store. If you know exactly what you're looking for, you can go like with a surgical knife. It's a little bit more work, but computed columns offer a better performance overall. So my suggestion to all my customers is get rid of JSONB object completely. If you can afford it, if you can do that, then go straight to relational because you have the best performance. Where it's not possible, try to use computed columns. When computed columns are not possible, then you go inverted indexes. And so
that's clear. That's clear.
John, do you see any?
Yeah, I don't have anything to add, but I think that how you described it, is a good rule of thumb because not everybody, depending on your use case, you may not have the option to either do the computed or otherwise.
Exactly.
And I think one thing that maybe I was thinking when we were talking about use cases is just, there are sort of these anti-patterns of JSON use, which would be, like you kind of touched on it, Fabio, which is just shove everything into a JSON field because you don't want to have to figure out how to correctly structure your database. And that is not really the use case.
Don't do that.
Yeah, what we're showing here is really powerful, or what Fabio is showing is really powerful for the use case where indeed it absolutely makes sense to store JSON or you need to for whatever reason.
And then Adrian wanted to know, when is the value computed?
It's computed immediately.
Immediately, nice.
Yes, otherwise you wouldn't be able to create an index of it, and you wouldn't have a performance improvement. Because if it's computed on the fly, you will still have to the work of extracting it and inserting it into the index, so that wouldn't be a performance improvement. Yeah.
Nice. David said, "Thank you for the answer." Using the stored approach is what they're using right now, but he would love to get rid of them. Let us know how we can help you.
Well, there's nothing wrong with the stored approach. And by the way, if you have changed your JSON in that you don't want to send that, so what you had as a stored column, you don't want to add it anymore through JSON. So you don't want to have CockroachDB constantly at every insert extracting the data and putting it as a stored column. You can convert at some point your stored column into a native column. And then you do just as normal insert, and you just simply extract it. But that's something you will work more in tandem with the application developer. So if you, as an application developer, you have this. That's why I'm keen that the application developers actually know how the CockroachDB works a little bit under the hood, because they can do all this performance optimization, and eventually they do pay off.
Adrian was confirming that the value is computed when it's added / updated. That's exactly right, Adrian.
Cool. So now we'll last a bit of performance, just a bit on a different side, on a tangent, but is using family groups. That is a performance optimization that not only applies to JSON object, but applies to any big payload, bytes, or big string, image file, whatever, and any object, any column that you must store, but you don't really frequently update, you don't really use that much. You just want to put it on another level. You just don't want to be in the same row as the other one. Is by using families. With family, you basically put in a particular object. In this case, we're talking about JSON. So you put the JSON object into a different family. On the key value store, that family will be stored in a different row, adjacent to the other row, but on a different row. So if you need to update or query constantly, you query the data, but not the JSONB object or your bytes object or your big string object, you bypass that. So you read less data and you rewrite less data. It's a performance improvement. Obviously, if your query constantly queries also that JSONB object, then it has no performance improvement if you constantly read it. At this point, you can keep it in the same row. This is something that, again, is true not only for JSONB object, but in general for any big object that you must keep, like an image. Think of an image file, some bytes, however, you don't query very often. And that really brings us to the labs, Raina, time check is a good time to start with labs. Any other questions?
How long is your lab?
It's about 10 minutes or something. That you should go through fast. I mean, we leave them as a to go also for our audience, and they can bring them home exercise. They can do them on our behalf. It's very simple, especially with CockroachDB serverless.
Okay, we're good then. Go for it. I am, however, going to try a chat overlay. One of the things we do with these modules is we are streaming over several platforms. YouTube, LinkedIn, Twitch. I think we're even on Facebook and Twitter. And so if you ask a question on one channel, we may accidentally answer on another. Something I'm going to try doing is adding this chat overlay on the side of our screen. We'll do this in the future with everybody from the beginning, but I'm going to see if someone messages from LinkedIn, if someone from YouTube can see it. So feel free to just test that out. We are now silent in our comments, but feel free to chat in there and let's see if we can see everyone's questions and answers on the left side of the screen. I'm so flipped. The camera flips, everything flips. Awesome. Thank you, Adrian. So I'm going to leave that chat overlay on. Please let us know if you can no longer see. Thank you, Cockroach. Let us know if you can no longer see the shared screen. We want to make sure that the information is shared first and the ease of use is a little bit lower down, but this is all about developer experience. And we want to make sure that you have the best experience possible. Let's start that lab.
Yes. So first, I shared my screen of a Cockroach Cloud, so our database as a service offering, and this is really, and CockroachDB serverless is really the best thing after Apple Pie, because it's just so easy for developers to create a cluster and just get started with it. You don't have to download it locally, starting it up, making sure it brings up again next time you switch on that again your computer. Here it's always up and running, and it's free. So I'll actually go through an exercise on how to create a cluster. So I logged in. Login is free. Nothing, you have to pay for anything. It brings me to the cluster page. In this case, I already have a cluster up and running. It's called Qt Otter. Again, this is a free cluster, and it's going to be a free forever cluster. But I want to create one. I want to show you how easy it is to create one. So I go to serverless. It's still in beta. It's for free. I choose my cloud provider, which dictates basically what region I want to go to. At the moment, we have one in the US, one in Europe, and one in Asia. And so it's again free. I choose my name if I don't like what is proposed. Again, confirmation that this is for free for you. And then I create my free cluster. And just check it out how long it takes to create your cluster. 1, 2, 3, 4, 5, 6, 7. About 10 seconds. Okay, done. The cluster is up. The cluster is up. It gives me connection parameters if I want to connect from the SQL client directly on my terminal, which is what we'll do. But if you prefer using dbeaver or DB Visualizer or any other GUI application, you have connection parameters, and it gives you details on how to do that. Very, very simple. And this cluster is up all the time. It doesn't come down if you don't use it. It's always up and running. Now, I already have one up and running already, which I already set up on my laptop, doing all that, downloading the key, etc. So I'm going to connect here to Qt Otter. So hope you can see my screen right. I'm going to connect. This is a connection string, and I'm going to here. Cluster is up and running. So I'm connected to the database, and now I'm going to go through the labs. The labs are available on the page that you suggested. And it gives you really details on how to do that. You don't need an extractor. It's all self-paced. Copy and paste is finally available on GitHub. So I can click this button here, and I will create now a table and insert some data. I'm going to import the data from GitHub, basically. I saved some data there. And then I'm going to count how many we see. So I'm going to do copy and paste. Makes it very easy. Create a table. Import job is done. Okay, 1. So basically, we inserted a database. I want to show you what this data looks like. So I'm going to copy this URL, open a new tab. So you see, it's a lot of data. Whoa. It's a lot of data. How many rows do we have? 1.
More than 3.
That's not the wrong. Exactly. That's not the right way of importing data. That's basically the goal of the exercise. Is do try to flatten this as much as you can, because that will improve the performance of your queries. You don't want to have one key value row. You want to have many, one for each object. Yeah. But this data is helpful at least to go through the functions that we discussed. So this is what the data looks like. Of course, I showed you here, but it's hard to make sense unless you are an X-Man. So this is basically what it looks like, nicely formatted for human consumption. We're going to go through some of these functions. The JSONB pretty. So I'm going to copy that. And let's go through some of this. I'm going to do that. Here. The JSONB pretty, what it returns me is a nicely formatted way of all the key pairs. And here you see that I'm extracting only the first level, that's value 0. I think it's just the first item. If your JSON object is an array, and you want to access the first item of the array, I believe that's how you do it. And then it gives me the key value pairs, nicely formatted. That's good for visualizing. JSONB each, however, returns to my SQL client a nice list of tuples. So this is great because I don't have to create it on application side. CockroachDB returns it on my behalf. JSONB object keys, very similar to before. It just returns me a list of all the keys. Any questions so far?
That's so, yeah, that first screen made my eyeballs bleed. That's awesome.
John, do you see this helpful? You, as a developer, do you see this very helpful for the developer to be able to receive the keys straight from the database without having to compile it yourself or compile it? Yeah, compile the list.
Yeah. I mean, absolutely. I mean, anytime you're looking at JSON data, the first thing you do is throw it into JSON pretty to look at it. And I like the key function as well. Does it handle nested data fairly well? Yeah. Like if there's levels of nesting where will it output keys, nested keys, or I know
yes. So this is just the keys, but in JSONB, in this case, I've just extracted. Let me do something. Let's see. I do where ID equals 0. I don't want to do jump. Yeah. So it returns more data. In this case, I believe it's just a flat. It's just a one key and value, key value, key value. But it will provide you with the entire thing, yes, if it's required.
Cool.
Yeah, that's pretty powerful. That's pretty nice. Okay, now we can drop the table. I don't need to tell you how to do that. Well, we're going to delete this data because it's pretty useless. And instead, we're going to import the data that is flattened. So let's review quickly the raw data. What's the difference? So now you see is a TSV value. Check on the top right is a 0 and then a tab key. So this is the tab. I know it's very small. Let me make a little bigger. You will see that on the screen, but yeah, this is the key. And this is the tab, the separator, and then you have the JSONB object. And further down, 1, the other ID, and then the tab. So this is a flattened. This is a flattened file. And I click here, copy, let's paste here. And the data is soon to be imported. Now we can see we have 110 rows. And now we can do something a little bit more interesting. For example, we can practice with operators. By the way, we have only a few labs. So give me another 2 minutes and we're done. So here, I want to just extract some data. Very simple. Again, using the string operator. So fetch or extract a string and call it this name, and count, do some basic aggregation. And then I want to do the same thing by summing the price. So again, with the cast function. So this is what it's going to look like. So I can create easily I can extract the data and do some operations on top of it. So one thing
actually, I was going to say, Fabio, I like this data because although it's like you could have created a data set that had like super easy to understand keys and all that stuff, it's actually, this is pretty typical of what you see in like big chunks of JSON data. You're going to see a ton of properties, and you're going to be running these things, to say, what does this data look like? Print out the keys, show me some stats on it, those type of things, and probably looking for that, needle in that haystack of JSON data that you want to actually query on. So this is great.
100%.
Yeah, now we're going to the fun stuff because it's query optimization. That's what we do all the time. I find it very funny. So I inserted more data. Now we have about 15,000 rows. And we want to do this query using native JSONB syntax and see how long it takes. So it takes execution. Let's run it one more time. Execution is 1 second. So, okay, well, that takes a little bit of time. Let's check the query plan. And sure enough, if I do the query plan, I have this dreaded full scan. That's the first thing we check as enterprise architect. Is your query doing a full scan? Because that's a no-no. We need to improve that. So we're going to improve it by making use of inverted index. In fact, I'm going to use a create inverted index on this table. It's going to take a few seconds to create. Once we do that, and we do the query plan, we will see that it's going to use the inverted index, which we have called index JSON inverted. Let's see if it's done. Yes, it's done it. Let's query the query plan. And sure enough, I see that it's using the JFlat is the table name, and then index JSON inverted is the index name. Before it was using primary. Primary, yeah, the details is right here. And so now I know that to find this data, I just need to span through this very little data. So it's extremely fast. And sure enough, I do the same query again. How long it takes me? 1 second? No, it took me 2 milliseconds. By the way, check this out. The time here is the sum of the execution plus the network. So I'm in Long Island. Maybe it took a little bit of time to go from, but it accepted it up in Iowa, I don't know. But it took 2 milliseconds to execute this query. Okay, so I think I'm conscious of time. We're going to skip the joins, but joins are supported operation. You can do joins on JSONB objects. I'll let you read through it. Actually, I will really invite you to go through the labs.
Yes.
Yeah?
Yes, please go through the labs. People are there on github.com/cockroachlabs/developer-success. Look for JSON optimization.
Cool. The last one I want to go through, Rain, because you asked, is about the computed columns. So let's do the same exercise with and without computed columns. So here is a good example where I'm running a query, and sure enough, it takes 334 milliseconds. And then I want to do the explain plan. So I want to check exactly what is happening. And I'm going to see that it's doing a full scan. So which is a no-no. Why? I thought we had inverted indexes. Yeah, but inverted index do not work for filtering for in the where clause. Not use, even though I have it. So it's not going to be able to leverage to do this piece of the SQL query. So what I need to do is do computed columns. So let's create a clone pretty much of this, but using computed columns. While this is creating, let's review a little bit what I'm doing here. So I'm creating a similar table as before, again with the same JSONB object, but I'm adding rseat as a stored computed column and I extract it from the JSONB object, and the same with attr19 and rprice. These are the columns that I needed in my query. So the most used columns, I want to make sure I extract them to native CockroachDB columns, and then I'm ready for doing again my my query. See how that works. So I do the explain plan. Now it's created. Let me do the explain plan on the newly rewritten query that outputs the same values. Okay, so sure enough, I am using a filter and I'm using the right index. So as you can see, I have a limited amount of data to check, and that will improve my performance tremendously. So let me rerun the query. How much did we saw it was running before? 334 milliseconds. So how much is it now? 20 milliseconds. So it's a great improvement. So it's a little bit of work to figure out how to extract it. Yes, I need to create another column. Might be a little bit of work, as some of the people in the chat have mentioned that they want to get rid of the stored columns, but they're helpful. So it's worth to go through that and do computed columns if, of course, you are querying all the time. If it's only once a month, then probably it's not worth doing that for sure.
Nice.
James, thanks. John, any considerations here?
No, this is really great. I think you mentioned maybe one limitation on inverted indexes. Are there situations, or do you want to kind of recap what situations inverted indexes kind of won't help a query?
Right.
It was in the where clause. So you have an item in the where clause. Let me go back to the lab here, where I said, okay, I want to have a query. My query says, okay, give me this data, select whatever, where my flat, and then extract this data, where the CS at 19, let me do it bigger, hopefully you can see my head, is like star, mom. So contains this MOM string. And you can say, well, sure enough, it should be easy to do that with an index, but not with an inverted index. That will not work with an inverted index. I can do that if I have a computed columns, and that's what we did when we have rewritten this as a computed column. So I can do where at 19 like 9. So this looks more like standard SQL, right? And it's not. I'm not extracting data from a JSONB object, and I'm doing it directly on a computed column, so something CockroachDB native. And that's why I get such a performance improvement. That's why the optimizer is able to leverage that. So inverted indexes are great, don't get me wrong, but they have some limitations.
Got it. That's great. And do you have any rules of thumb, maybe for using computed columns on JSONB objects, like either kind of workload type patterns or even like number? Like you probably don't want to create like 50 computed columns on your JSONB column from your JSONB column, but what's your recommendations?
Start with extracting as a computed columns the most used columns in your queries, especially if they have to be casted as an integer, if they have to be casted to some other type that is not string, because you need to do aggregation, because that will improve. You always need to think about it. Okay, what is Cockroach is gonna do with my JSONB object? So you need to extract it. There's a big file like this. Then you need to get only this bit of data, and then another piece of data. And then I need to cast it as an integer so that I can do a sum of it. It's a lot of CPU cycles. It's a cycle to go through. So how can I make it short? So why don't you just simply take it and put it as a column directly along with the other objects as a native column already stored as an integer or as a double? It's much faster. So you need to think about that terms. I know the developers don't like thinking maybe nitty-gritty stuff like this, but it does pay off. And again, we as enterprise architects, that's what we are here for. We help using everything under the sun related to deployment, but also query optimization.
Yeah, as a matter of fact, we did a query optimization module. Let me get that link for you. And the module is available on GitHub as well. Ooh, the link is quite long. It is on the right.
Yes, and again, those are all self-paced labs. You can do them quickly, independently using Cockroach Cloud. And I really like the serverless one. It's free. I don't have to bother about bringing it up, bringing it down. I just need to clean up after myself, dropping the tables. But it's always up and running. It doesn't cost me anything. Why not? I mean, it's so easy.
Yes.
And if I want to scale up, if I want to try out something bigger, I can always do it for a limited amount of time and scaling it down when not needed. So only is a pay-as-you-go consumption. So, yep. That's all for me, Rain. Back to you. Any other questions?
That was awesome. I've put the query optimization video. It's saved on YouTube. Definitely want to remind people, if you are watching this somewhere other than YouTube, be sure to subscribe on YouTube as well. And the reason for that is, well, personally, I find that the chat interface and the viewing is more intuitive, but also you have all of these videos are available in our library. It's the only place where all the videos are saved is on YouTube. But yeah, does anyone have any questions? We have another minute.
Is John's dog still sleeping?
Oh yeah, we totally. Also, we want to see the dog. Sleeping. I am going to maximize John a little bit. The puppy in the background of John is an older boy who
13.
mostly sleeps. So, and
he
often
was,
right there.
Yeah, he was having a dream earlier where he was making his little whimpering noises and moving. It was really cute.
100%.
Yeah.
Yeah. And I'm with Adrian. We need a dog cam for the fourth. Fourth person, fourth guest.
Oh yeah.
Definitely.
That's a great idea. Cool. He is very relaxed. But that was a fantastic presentation, Fabio.
Thank you, John.
100%.
Yeah.
If you are interested in hearing more, be sure to subscribe to YouTube or wherever else you are watching the stream. Tomorrow at the same time on whatever channel you're watching, we will have our office hours, which you can ask questions from today. You can also ask us anything about CockroachDB or Cockroach Labs. Neither one of you are joining me tomorrow, are you? It's actually... I forget. It's two other people.
Two other people.
It's office I with two other enterprise architects, experts. Mm-hmm. I will be here in the next few weeks. Our next show is 2 weeks from now, and we are going to talk import, backup, restore. John, that's you, isn't that?
Is that 2 weeks? So I better get to work.
Yes, definitely. So import, backup, restore, that's definitely an important subject. No? Okay.
Yes, absolutely. It's one of the key in every single deployment. Without the capability to do backup, restore, import, export, it's hard to be production ready for that. So absolutely.
I want to hit some use cases for import for getting up and running on Cockroach serverless. If you have an existing application that you want to get running, we'll be looking at some data sets, importing some data sets and seeing what kind of issues you might run into, how to solve them, those type of things.
Awesome. And if you have any questions, be sure to visit us tomorrow, because as for today, the music started, so we gotta go. Let us know if you like the chat overlay over there, or if it's too crowded. If you couldn't see the code, let us know. All questions count, all feedback counts, and we'll see you on Slack. There we go, there's the link. Let us know, as always, how we can help you on your developer journey. And for today, have a great day. We will see you tomorrow. Thank you, John. Thank you, Fabio. And we'll see you next time. Bye.
Take care.